You've probably heard of and used saturation before. At its core, it's an effect shaping the incoming sound, making it sound warmer, more present, or at extremes distorted. The louder the incoming sound, the more the saturation changes its character. That's what drive is. It's a volume knob that makes the input louder and therefore makes the saturation more extreme. In mixing, I tend to think of saturation as having two main effects. I'll try to break down here, followed by some tips on how to control it and avoid unpleasant side effects. When people talk about warmth, harmonics are usually what they mean. For this demo, my input was a plain sine wave. As you can see in the spectrum analyzer, the saturation added all these overtones to it. The more complex the input, the more complex the overtones. Because our ears are more sensitive to higher frequencies, this can help sounds cut through the mix. This becomes nowhere as apparent as with a sine wave sub. So here we have a sub without saturation, just a pure sine wave, and here with saturation. As you can hear, the saturation added a bunch of high frequencies to it. The second use case is using it to control dynamics. Saturation also has another effect on the waveform. It chops its peaks off. What you can see here is a snare drum sent into a saturation and turned down again to compensate for the drive. As you can see, the saturation introduces a kind of compression, like threshold to the sound, above which the peaks of the waveform are removed and traded in for harmonics. This can be very useful for making sounds louder and keeping them below a certain gain. The quieter parts of this waveform remain unchanged. Different to a compressor, this effect has no attack or release time, it happens instantly, which may help explain why sometimes compressors with fast reaction times sound like saturations. Here you can hear the drum without saturation, and here the same drum that's been compressed by the saturator. This effect can range from very subtle to very extreme, depending on the input material and its volume or drive. It being barely audible can be used to your advantage. Because saturation depends on the input volume, the drive volume compensation is vital to make sure you can judge it accurately. When you turn down the output again by the drive, you make sure that what you're hearing is actually the change in sound character introduced by the saturation and not just a difference in gain. Our ears are very sensitive to volume changes, so these can quickly override any changes in timbre. Because the saturation is so sensitive to changes in input level, we can use EQ to affect which parts of the sound are getting most affected by it, even though we turn them down afterwards. Because they drive the saturator, this set of sounds sounds different. Without the EQ, and now with the EQ. Once you start using filters like this deliberately before or after the saturation, you start really being able to control it. A setting you've probably seen in some saturation plugins before is oversampling. Without going into detail here, the harmonics the saturation adds can sometimes be so high above the range of human hearing that your sample rate is not able to accurately represent them anymore. This results in quite an ugly artifact known as aliasing, and among some other methods, oversampling is one way to reduce it. The sample rate is temporarily raised so that higher harmonics can be calculated. These are then filtered out and the sample rate is reduced again to your project's default. Whenever you're saturating high frequency sounds, therefore, it can make sense to enable oversampling to prevent these artifacts. The example you can see here is a sine wave around 10K, being saturated without and then with oversampling enabled. This is quite an ugly sound, so I'm not gonna play a demo here. That was it about saturation. See you in the next one.